it's going to be a what? Tau max. And this case, this is in plane. Okay. So if you have a condition like this, it is okay to use what? 2D Mohr circle. Yes or no? Right? Because if you were to draw 2D Mohr circle, right? If we just consider X and Y, it is the biggest circle that you can see, right? We already draw the bigger circle already. Because the other two circle I've drawn is inside the what? The in-plane circle, the XY plane. So for this case, it's okay to use 2D Mohr circle analysis. Okay? You don't need to use 3D Mohr circle analysis. Okay? So let me write the condition or the formula out. So tau max for this case is equal to tau max xy is equal to tau max yx. Okay, so this will be equal to stress x minus stress y divided by what? Divided by 2. Okay, so this is your in plane now. Okay, so if we let stress x to be equal to stress max, stress y is equal to stress mean, right? So tau max is equal to stress max minus by stress mean, okay, divided by 2. Okay, so that is the expression. Now again, this is only true based on condition number 2. Okay, where stress x is positive, stress y is negative, stress z is equal to 0. Okay, and then we have a third condition. Okay, so we already have 2 conditions, and then we have a third condition. Okay, I think I have to carry on. So the third condition is such that okay, condition number 3. Okay, so this is your x, y, and this is your z. Okay, so it's such that now stress x is less than stress y, stress y is less than stress z. Okay, and all are positive. Okay, all are positive. So I'm going to copy this image over here. So now all of them are positive. Okay, so stress z over here is not equal to 0. They are all what? Positive now. Okay. So when that's the case, I'm going to draw more circle again. So I'm going to ignore the compression. I'm going to focus on positive. So shear clockwise. So it says that stress Z is the highest value. So this is stress Z. And then this is your stress Y. Okay. And this is your stress Z. So if you have the interesting thing is this: if you have three stresses that have magnitude, you don't mind using 3D Mohr circle, right? You have to represent X, Y, and Z. The problem comes where you have when stress Z is 0, okay, and the other case also condition number 3. You just say, okay, if stress Z is 0, we can use 2D Mohr circle. No, not necessarily true. You can only use in condition number 2, but condition number 1 you cannot. So for this case, it's normal. Okay, you say, okay, if it's 3, if it's X, Y, and Z have value, I have to use 3D Mohr circle. Okay. So this is your, I mean, that's the way I think. Okay. I don't know, do you think the same? Okay. So this is point Y and this is point X. Okay. So we go to draw the first circle again. So for this case, this is your XY plane. So this is your in plane. And you realize that your in plane will not be the biggest circle. So if again we were to draw okay, so this will be your tau max XY. Okay, then we draw another circle. Right. So this is your YZ plane. Right. And over here, you realize that this is even a smaller circle. So this is a shear max YZ plane. And then our last circle, as you can observe now, is going to be the biggest circle. Right. So this is for your XZ plane. So these are your out of plane. Okay. Likewise, for this case, this is also your out of plane. So for this case, as I said, you have no problem using 3D Mohr circle because 3 components all have stresses, right? So now we know that the maximum stress is going to be out of plane. So this will be our shear XZ or shear max XZ, and this is your tau max, right? So the tau max change, right? So we know that the tau max is equal to the tau max XZ is also equal to the tau max ZX. Okay, and then we know that tau max is equal to stress Z minus by stress X divided by 2. So if we let stress Z is equal to stress max and stress X equal to stress mean, right? This can be also expressed as tau max is equal to stress max minus by stress mean divided by 2. Okay, so we have seen 3 conditions. Okay, so now let's do one example before yeah, I'll finish one example, and there's going to be a tutorial on Thursday, okay, to carry on with a few more example on Mohr circle. Okay, so let's look at another example. Now this example over here, we have our shearing stress. Sorry, this is our transformation, and this is our Z. Okay, so we are going to draw. I'm going to do slightly different. Okay, and I'll show you what is the difference that I'm going to draw now. So this is a 3D element, right? And this element is not on its principal plane. So you have over here 120 megapascal, and then you have a compression coming down 60 megapascal. Okay, and stress Z is equal to 0. But okay, over here you have a 30 megapascal shear. Okay, so we're going to draw Mohr circle on this. Okay, so this is your point X, and then you're going to have your point Y, and this is our point Z. Okay, so I'm deliberately putting the shear in there. Okay, and it's not more difficult or less difficult. Okay, so we're going to construct a 3D Mohr circle. Okay, so we have our axis. So we'll start from minus 80, 60, 40, 20, 0, 20, 40, 60, 80, 100, 120, 160. Okay. Oh no, 140. What do you mean? So this is our normal stress. Okay, this is our normal stress. And then our shearing stress. I hope wait, 20, 40, 60. Nope, not enough. I need more. So we're going to bring this down to here. Okay. Now I believe I enough. So I have 20, 40, 60, 80, 100, and then minus 20, minus 40, minus 60, 80, 100. So that is my shear. Right, so on our shear, element rotation clockwise, element rotation anti-clockwise. Okay, so now we know that stress Z line is on here. Okay, then we have our 120. So this is our stress X, and our stress Y is minus stress is minus 60. So that's our minus 60. So that is our stress Y. So it's easy to identify. So if we look down here, right? So stress X is equal to positive 120. Stress Y is equal to minus 60. Stress Z is equal to 0. Shear XY is equal to shear YX is equal to plus 30 megapascal, right? Because it's positive shear. So we know that at the center over here, this is your point Z, because normal stress 0, shearing stress is also equal to 0. That's our point Z. Then we look at our shear. We have